Hey, it's John Broadwell, and I am excited to say that I have released version 2.1.2 of the firmware for the Serial Wombat 18AB chip with a bunch of great new features. The focus of this is moving the Serial Wombat 18AB from a smart I/O expander into a full-blown embedded systems real-time control coprocessor for your Arduino or your Raspberry Pi, MicroPython board, PC, whatever. Before we talk about the firmware, I also want to make you aware that fully assembled Serial Wombat 18AB boards with an onboard red label chip are on their way to Amazon right now. I expect those to be available for purchase by the beginning of May. They come in a one pack for $12.99, which is more expensive per chip than the kit, but you don't have to put them together, so you'll save some time. And those boards also include the quick connectors and the ESP01 interface on board, as well as the 3.3 volt LDO. All of those are optional parts that are not included in the kit. So, those are going to be my go-to for the chip going forward, and I'm hoping that'll expand it to a lot of you guys who like to plug things together with DuPont connectors and are not real big on soldering stuff. So anyway, that's a huge step forward for us here at Broadwell Consulting with the Serial Wombat boards. And so now let's talk about the new firmware, which we're also very excited about. So let's take a look at some of those features. And I would note that comments to the various videos that I'm going to talk about, links to the tools, links to the firmware update package are all available in the comments below this video. First, there's a new pin mode for H-bridge control, and we've seen that in some of the preview videos. Right now, it services any board that takes two inputs for a bridge, so PWM on one, digital I/O on the other, or vice versa. So like your LM298s, your DRV 8833s, 8871s, lots of boards will take input in this style. I expect in the future to be able to add support for an N-channel FET and a relay, or two relays that would not have proportional control but could turn on and off and go back and forth. Additionally, there are some drivers out there that require 3 pins, 2 directional pins, and an I/O control, PWM control. That'll be coming in the future, as well as future versions will support brake and coast. But for right now, when the PWM is 0, when you're not moving in either direction, it turns them both off. So anyway, this is a major, major improvement towards being able to do robot control and other real-time embedded type control features. The queued pulse output, and this was something I wanted for a project I was doing. I had a little pump that I wanted to run a given pulse for, and I wanted exact control over that pulse. So what this lets you do is queue up a series of pulses. The Serial Wombat chip can either send them out immediately as they come in, or you can say pause the queue up a series of pulses to go out, and then re-enable it. And so that will enable things like IR remote control pulsing and things along those lines. So there'll be a future video on that one. I haven't previewed that one yet. It is supported in the libraries and things like that. Next, the Quadrature encoder pin mode. This is one of the most popular pin modes on the Serial Wombat 4B. The Serial Wombat 18AB provides all of that functionality and now is adding to it. First of all, moving towards this real-time coprocessor idea, we have frequency measurement. A lot of people use the Quadrature encoder to read user interface rotary controls, knobs, but you can also use it for motor positioning. And along with that, it's nice to be able to see how fast the motor is moving, because sometimes you may be controlling it using a PID loop for position. Other times you may be controlling it based on speed. So we support that. As far as user interface capabilities for the knobs, I've added min and max settings, increment settings, and the ability to modify other pins' data. So suppose you had a number that you wanted an input to range from 0 to 100. Now you could potentially use 2 knobs to do it, one that would increment it by 1, one that would increment it by 10, and it wouldn't go below 0. It won't roll over if you set it up like this, and it won't go over 100. And so you're now kind of moving up the food chain, and the Arduino or MicroPython board only has to say what's the current setting, as opposed to keeping track of the net changes of the rotary encoder, which in turn is yet a higher level of abstraction than, say, the standard Arduino rotary encoder of just counting interrupts. So anyway, moving again towards this idea of offloading as much functionality into the serial Wombat chip as possible so that the main host can function at the highest possible level. Ultrasonic distance sensor, again, offloading common tasks to the serial Wombat chip. It can trigger a servo movement based on receiving pulses. And so what this does is it lets you create a radar style display. You tell it how many points you want in that radar display, and it stores the distance for each of those pulses in an array. And so you can at that point, you don't actually have to control the servo or the ultrasonic distance sensor. You just ask the serial Wombat 18AB chip, hey, I want you to set up and take readings every 15 degrees. And then you just read that array to find out, based on the last set of sensor readings, how far away things were at each of those different angles. So we did a quick preview video on that. I'm still due to do a whole pin mode sum up of the ultrasonic distance sensor, and I'd been waiting to do that because I knew this feature was on the horizon. Well, in version 2.1.2 it's here. The PID control has been massively updated, and some of the internal math has changed. The order of the P versus I and has changed the flow diagram. There's a couple of different ways to implement PID, and I found that the old way, version 2.11 and earlier, didn't work as well with the fixed point math that I use as this does. So anyway, version 2.1.2, you've seen me come out recently with a bunch of PID videos. That's because it's working really, really well. I'm really excited about it. You may have, if you're using the version 2.1.1, you may have to change your K, I, and P constants, PI and D constants, in order to make this this work. We've also added some wind-up elimination. Essentially, if we get to saturation, we won't let the integrator keep growing in one direction or the other. And we've added a lot of visibility into system performance, where you can actually see what part the K, the I, and the P are contributing to the output, as well as the instantaneous error and the wind up of the integrator. All those things are visible. And if you look at the video that is linked up above and in the comments, you can actually see that working over the WombatPanel, which is and we added a lot to the WombatPanel to make all of that stuff visible. So anyway, really moving again towards that idea of being a real-time coprocessor. Don't be surprised if we don't have a robot control board coming out soon that leverages all this stuff. Input integrator transform. So you guys may have seen some of the videos I've been doing up till now of controlling a robot. Well, we want to be able to use a joystick. And when you use a joystick, you don't want the robot to go to where the joystick is. You want the robot to move in proportion to how far the joystick is being depressed. In order to do that, you need to be able to integrate the input from that. And so this is a new function that's available on all of the serial Wombat proportional input pin modes as part of the processed input pin mode. So, you know, here's there's definitely videos now that are linked to below that will demonstrate that. I'm really excited about that as well. Output linear interpolation. So as you know, one pin of the serial Wombat can control another pin. And sometimes you want to do a transform. We have a new transform mode where you can give it multiple different points and they work together to transform into an output. Computing efficiency outputs, the Quadrature encoder hardware mode, the ultrasonic distance sensor, the PS2 keyboard input, and a couple of the other ones. The ones that run at the 57,000 hertz sampling time. I've improved some of the assembly language routines around that so that you can run a bunch more of those pin modes at the same time without overloading the serial Wombat chip's capacity. And I'll be coming out with a video here in the fairly near future that talks about how to measure and manage the throughput. Most people don't need to do that, but again, as we move into being a real-time coprocessor, you know, we're going to have to make sure that we hit every embedded system's deadline so that nothing falls on the floor, and making sure that we're not wasting cycles is a big part of that. The Arduino library has been updated with version 2.1.2 features. They're all fully supported in the interfaces, and you can see those in the GitHub pages. Similarly, the MicroPython library has been fully implemented with all of these features. The C# library has been updated with all of these features. The Salier protocol analyzer has been updated with all of the V212 commands. So if you're using the Salier protocol analyzer to look at the serial Wombat protocol, you can see them all properly. And finally, the WombatPanel has had a major update with version 2.1.2. Many of the modes have code generation. Some of the videos that I linked to show how to do that. And it also has real-time protocol decoding. Essentially, I ported the Python code that we use on the Salier to the serial Wombat C# code. And so it will show you on a line-by-line basis the commands it's sending and what they mean. So that's it for now. Really excited about this. Definitely recommend you upgrade your firmware. There's a lot of great stuff in this release. There's a handful, as of April 19th, there's a handful of green boards still at Amazon that'll have the V211 software in them. I just sent in a batch of 212s, but I can't guarantee who will get what. So anyway, when you open it up, check the version. If it's prior to 212, then definitely do an update. Till we talk again, have fun, keep making stuff. The Serial Wombat firmware is available on GitHub and is constantly being updated. Subscribe below so that you can see the latest features and videos that come out as we fix bugs and add new features. The Serial Wombat open source project was created by Broadwell Consulting Incorporated. Broadwell Consulting Incorporated provides help developing medical devices with a focus on developing embedded firmware, which is compliant with IEC 62304, ISO 14971, and ISO 13485, as well as remediation assistance for products already in production. For more information, contact John at Broadwell Consulting. Support requests for Serial Wombat should be sent to help@serialwombat.com and will be answered on an as-available basis. Also, feel free to leave your question in the comments below.